Because in second chapter, the concepts related to the gravitational plus circular both are interconnected, because you observe that in the questions of the circular motion, there is also a link of the gravitational force or the gravitational field like that. Okay.
Yes.
So basically, this is second chapter, and this chapter is known as gravitational field. This one is not much very difficult, just like the previous one, but it might be slightly, we can say that a lengthy one as compared to the first one. So basically, in IGCSE or in AS, you already discussed about the concept of weight W equals to mg, right? So basically, that G is basically gives you the concept of gravitational strength, right?
Yes.
And if we talk about the gravitational field, because the name of the chapter is gravitational field, so first of all, we need to explain gravitational field, because they will definitely ask about the definition of gravitational field. So we know it is just like the electric field, right? The region around the body where it mass experiences a force due to the gravitational attraction of another mass, right?
Yes.
So we can say that a region of space where a mass experiences a force due to gravitational attraction of another mass. So basically, this is the concept of gravitational field, right? And the very most important thing in the gravitational field, we studied about magnetic field, we studied about electric field, right? So those fields are, or those forces are attractive and repulsive, right? It may be repulsive, it may be attractive. It depends upon the charges and it depends upon the poles. Like north and roll repel each other, north south attract each other, right? But the different in the gravitational field from the other field is that gravitational field will always attractive. It will never be repulsive, right?
Okay.
So the most important thing is, because they ask in past papers also, that what is the difference between gravitational field and normal electric field, right? So we can say that uh, gravitational forces cannot be repulsive. Gravitational force cannot be repulsive. Okay. So this is the concept of gravitational field. This is the most important point, because this will help you to write the difference between normal field and the gravitational field. And we know the formula of weight W equals to mg, that will give you the concept of gravitational field or the gravitational strength. So this is the equation, we already know about it. So we are not going to discuss about the unit, because we know that unit can also be find out by Newton per kg. So that is not a very big deal, right? And we also know that on the specific planet or on specific, let's suppose if we talk about Earth surface, so value is constant, and that is equals to 9.81 Newton per kg, right? Sometimes we used to write 10 round of value, but now in the syllabus change or in the new update of the syllabus in IGCSE also, now they used to write 9.81 rather than writing 10. Okay.
Okay.
And the next thing is, because we know that we are talking about the gravitational field, so there must be some direction also, just like the charges or just like the magnetic uh, fields or the forces. We draw the repulsive attractive diagram for those forces. So same goes for the gravitational field also. We know that all fields are the attractive one, so there is no repulsive force. So all the direction of the gravitational field or the gravitational force will be in a same line, right?
Yes.
So if we talk about the representation of gravitational field, we are still talking about the same topic, right? Gravitational field. So the very first point that is related to the gravitational field, that point is gravitational field around a point are radially inward. Why inward? Because we know that because of force of attraction. So this is the first point regarding the graphical representation of gravitational field. And if we talk about the second point, so according to the second point, uh, just like the electric field and the magnetic field, that the gravitational field line are also the uniform, right? So gravitational field will be uniform. It means that the field strength remains the same everywhere, right? Or we can say that at all points. Clear? Any confusion till now?
No, it's clear.
Okay, and one more point, because I'm writing this point because they will ask in the theoretical concept also that write 2 points, 3 points related to gravitational field. So that's why I'm writing. And the third point is these field lines, these field lines are equally spaced parallel lines. Parallel lines means that they will never intersect each other, right? So if we talk about the example of the point mass, that is the first point that we used to write over here. So according to the first point, if we consider a point mass, so for that we used to draw lines like this. and we can just simply draw all the lines. So in this way, we can just simply draw radially inward direction, right? So for a point mass, all field lines are acting towards the center and all are radially inward. And let's suppose if we consider for any specific surface, let's suppose if we are having Earth surface, so for Earth surface, we need to draw equally spaced parallel lines, and those lines will be like this. So this representation shows you the example of second and third point, that these points, these lines are gravitational field lines are equally spaced parallel to each other, and all are again radially inward towards the center of the circle or towards the surface of the uh, earth, right? Any confusion?
No.
Okay. Okay, let's suppose now in next concept we need to discuss, let's suppose if we are talking about two planets, right? We discussed that gravitational field are always attractive and we know about the gravitational field. But let's suppose if someone asks you that how to calculate the value of gravitational force, right? Because this is gravitational field, that is the value of G. But let's suppose if someone asks you to calculate the gravitational force or the force of attraction between two objects, so how to find out or how to calculate that value? So that is the question, right? So for that purpose we need
Okay.
to use Newton's law of gravitation. So we need to know about Newton's law of gravitation, and according to Newton's law of gravitation, statement is very much simple, and statement is the gravitational force, the gravitational force between two points. Now we are taking example of two planets. Let's suppose 2 point masses, they may be anything. So the gravitational force is directly proportional. So the gravitational force between 2 point masses is directly proportional or proportional to the product of their masses, and inversely to the square of the distance. between them. So law is slightly, we can say that the lengthy one, but it is very simple, or we can say that the wordings of the law is very simple. We can say that in this condition, the actual law is, if we want to find out the gravitational force, so we are taking two bodies, and between two bodies, the force of gravitation is directly proportional to the product of their masses. Let's suppose if we consider two planets, so these are two planets, let's suppose, and we can easily identify that from their center we can easily find out their distance. And the second thing is their masses. This one m1 and this will be m2. Okay, and they are going to apply a force of attraction. So force applied by body 1, force applied by body number 2. Okay, and if we want to write the equation for this, so equation is very much simple. First of all, gravitational force is directly proportional to product of their masses. So we can say that F is equals to, or F is directly proportional to, first m1 m2, it means the product of their masses, and the second thing is inversely to the square of the distance. So F is inversely proportional to the square of their distance. Okay, so F is directly proportional to m1 m2, and second is inversely to r square. And if we combine the values, so finally we will get the final answer that will be equal to, so this is the final equation, right? And in the final equation you observe that there is a quantity of capital G. Okay,
Yes.
what is capital G? That will be a constant. And what is the meaning of that constant value, and which quantity, or what will be the constant value for that symbol capital G over there? Because we know m1, we know m2, we know r square, we know the value of F that is related to force, but actually G is Newton's gravitational constant. So this is Newton's gravitational constant, simple, right?
Yes.
So basically, this is the constant value, and the value of this capital G will always mention in your uh, data book, or the constant values that is written before your paper. So you will get the value, and the constant value will always be equal to, if we want to write the value for a small capital G, so the value is equals to 6.67 exponent minus 11 Newton meter square per kg square, right? So this is the value of Newton's gravitational constant, and it will remain constant for, and this is universal constant, so we can easily apply this on any planet or any body on the earth or out of the earth or universe also, right? And this is also known as the inverse square law. Inverse square law in this sense, if we take masses, because mass is a constant value, right? It will remain same. Okay. So mass of the body remains constant. Okay, so both, for both bodies, mass of the both bodies will remain same. Only the value of R may change over there. So in simple words, we can say that it can also be known as the inverse square law. Inverse square law in the sense, that force is inversely to the r square, right? If we take m1, m and capital G as constant, so if they ask you about to write the equation or to drive the equation for the inverse square law, so that's why you need to know about that, what how we are going to write it in inverse square law method. Okay, so basically we discuss about all the quantities, all the factors in Newton's law of gravitation, and according to inverse square law, we can simply say that that if the distance between two bodies or distance between two planet increases, so what will be the effect on the gravitational force? It will increase or decrease. Let's suppose if we are talking about that, if the distance between
If we increase the distance, the force will be less.
yes, and let's suppose if the distance between two planets will be doubled, so
Then force will increase by 4 times.
increase or decrease, because we increase the distance by
Decrease.
2 times, so force will decrease by 4 times, right?
Yes.
Because we know there is a square, so 2 square equals to 4. So that is the concept, right?
Okay.
So that helps in the reference of inverse square law, that what is the meaning of inverse square law and how to write that inverse square law, and why they will ask about inverse square law, right? So that is the factor, because we know that is driven from the basic formula, but still we need to know because we know the concept but we don't know the term. Okay, any confusion till now?
No.
Okay, so next concept is related to basically, let's suppose now we know about the concept of the gravitational field, and we also know about the concept of the uh, centripetal force, right? Okay.
Yes.
So basically, now what is the concept is when we are going to consider these two forces, just like the previous question that we did yesterday, that the frictional force and the centripetal force both are towards the center, right? Both are in the same direction. Okay. So if we want to discuss the concept with the reference of the gravitational field plus the centripetal force, right? Because both are now towards the center. Okay, both are towards, we can say that the radially inward direction. Okay, so next
Okay.
topic is related to circular orbit, or we can say that we can find out the speed from that formula, or we can also find out the time period, and in short we can also say that we are going to drive Kepler's law, right? I'm not writing directly Kepler's law, that what is Kepler law, and we are not going to start from that because this is a very derivative part section. So if they ask about the velocity, so you may also drive velocity from that formula. If they ask you about the time period and the radius, so we will also drive that concept. Okay. So let's suppose
Okay.
if we take the reference from Kepler's law. First, we discuss all the derivation, all the concept. Then finally, we write the statement of Kepler's law, right? Otherwise, it will be difficult to understand that when we are going to solve Kepler's law. So basically, if we start from the Kepler's law, so we already discussed that there are two bodies, right? Two bodies are attracting each other, or we can say that two bodies are applying force towards each other. So let's suppose if we consider one body, or we can take example of our Earth and the Moon, right? Moon will be smaller in size. So this is the distance between from the center to the object, right? And we know that centripetal force is going to be applied in the same direction towards the center of the circle. Plus, if we talk about the gravitational force, right? So gravitational force is also going to be act towards the center, right? Okay, clear? Any confusion?
Yes. No.
And let's suppose if we consider the path of that yellow object, that is moon actually, let's suppose. So that is actually moving in a circular path, right? Okay, so that yellow object is actually moving in a circular path. So we know that when object is moving in a circular path, so the direction of velocity is always tangent to the circle. Okay,
Yes.
so it will always tangent to the circle. This will be the direction of linear velocity or linear speed, right? Okay.
Yes.
Okay, so in Kepler's law, we were talking about that object is moving tangent to the circle always, right? Just like the uh, centripetal force. So we know that both gravitational force and the centripetal force are perpendicular to the direction of the travel of the planet, right? So one thing that we observe from the diagram is that both the gravitational and the centripetal force are perpendicular to the direction of travel, right? In short, we are saying that the tangent direction is actually perpendicular to the gravitational force and the centripetal force, right? So both are perpendicular to each other, very simple. And we know that both forces are acting in the same direction. So Fg is actually equals to Fc, right? And you know the formula of Fg, we just write that formula that Fg is actually equals to m1 m2 over r square, or we can also write it as, let's suppose the mass of the large planet is capital M and the mass of the small planet is small m, right? So we can also write this equation capital M small m g over r square. And what is the formula for centripetal force? That is mv square over r, right? We know that one value of r is cancel out because r is on the both side when we cross multiply, so small m will cancel out, one value of r will cancel out. So finally we will get the value of v square, and v square will be equals to gm over r. Okay.
Okay.
So you can see that this is the value for v. It means that if we want to calculate the speed at which the planet is revolving or planet is moving in a circular path around an other planet, so we can easily identify, we can easily calculate from this formula, right? And
Yes.
we know that the direction is continuously changing, that will produce the centripetal acceleration, right? We already know that thing. Okay. So basically, previously in previous chapter, we also uh, discussed the concept that is related to the orbital speed, that is the angular speed. What is the formula for angular speed? If you remember, v is equals to 2 pi r over t. Okay. Or 2 pi f, right? So
Yes.
we can say that for the orbital time period, because we got the value of v, now we are interested in to find out the value of t, that how long it will take, or what will be the formula, or what is the factor that actually gives you the concept of the time period for one complete orbital rotation, right?
Yes.
For the orbital time period, that is capital T, to travel the circumference of the orbit, that is 2 pi r. So we can write this equation like this: v is equals to 2 pi r over t. Okay. And we know that we drive equation number one, let's suppose this is equation one, and in this equation, let's suppose this is equation number two. Now we can see that both consist the value of v. Let's suppose if we just substitute the value of v from equation number two into equation number one, right? So that will be something different, right? What will get? Let's suppose if we compare the values,
We will get 2 pi r over t
yes, we are
is
actually
equal
putting
to,
the value of equation 2 in equation 1. So equation 1 will be 2 pi r over t whole square is equals to m over r. Okay.
yes.
Because we are interested in now time period, not in the speed. So that's why we replace the value of speed. And finally, we can say that the final equation will be equals to 4 pi square r square divided by t square is equals to gm over r. Okay. And we know that if we multiply these values, cross multiply, so that will be equals to 4 pi square r cube is equals to gmt square. Okay.
Okay.
Now if we highlight the constant values, right? So 4 is the constant value, pi square is the constant value, capital G is the constant value, and m is the constant value, right? So if we just make all the quantities in a single form, so all quantities are constant rather than r cube and t square. So we finally got t square and r cube if we add all the quantities into the constant. So your final equation will be like t square is equals to 4 pi square over gm into r cube, right? Okay.
Okay.
And you know that if you want to replace the constant value, so constant value can be replaced by the directly proportional sign. Okay, so we can replace all these constant value because you know that 4 is number constant, pi is number constant, value of g, Newton's law of gravitation from the Newton's gravitational constant, capital G, that is also constant. Capital M is the mass of the body, so mass of the planet is also constant because during the motion the mass remains same. Okay, so that's why we keep
Yes.
all those quantities as a constant. And finally, we got the concept like this. T square is directly proportional to R cube. Okay. So this is actual Kepler's law. Okay.
Yes.
So in simple, we started from the Kepler's law concept, and you can see that derivation is very much simple, right? And they will ask for 2 or 3 mark in your exam also to drive the Kepler's law, or they will ask like this that drive the equation or drive the relation for the time period in terms of R. Okay, so basically they are indirectly asking about the Kepler's law. Okay. So
Okay.
we got the equation for Kepler's law. Now let's write the statement for that. So our law will be completed because we need to know about the statement also. So we can say that for planets or satellites, in a circular orbit, about the same central body, the square of the time period is proportional to the cube of the radius of the orbit. Okay, you can see that statement is again very simple, just defining the basic concept. So just like the previous law, F is directly proportional to G M1 M2 over R squared. So this is also very simple statement. But if we write the statement in the start, so that will be difficult to understand that what actually we are driving. So you will always be confused that when we will drive that value, when we will drive that value. So that's why we take the reference from the circular path and take the reference that both forces are equal. So we just started from basic formula, and once we got the basics, so other part of this derivation is just the mathematics, right? There is no other additional concept, just like the previous chapter. Okay, because you can see that all steps are just like the mathematical step. We are just shuffling and just plugging the values into a different formula. Otherwise, all the thing is very much simple and very much constant. Okay. Any confusion?
No, sir.
So basically in this chapter, we discuss about Kepler's law, Newton's law of gravitation, and the gravitational field constant, right? And in next class, we will discuss about the value of g with altitude and with depth, right? Let's suppose if we move away from the center of the earth or from the surface of the earth, so what will be the value of g? It will increase or decrease. We need to discuss that. And we also need to discuss the concept between two planets, or let's suppose we can say that the gravitational potential, right? Because if we place a planet away from the other planet or close to the one planet, so what is the concept of gravitational potential? Because that gravitational potential is also important one, because many questions are related to that one also in exam. So this chapter is very much important as compared to the previous one, because in previous chapter there is also a concept of this chapter, right? So that's why this chapter
Yes.
more important. Okay. So we try to
Okay.
complete 90 or 95% in the next class of this chapter. Okay, because there are derivations takes time. Till then, practice the question from a circular motion, right?